In this example, it's probably the most challenging problem on this particular topic. There's combining a lot of ideas, but you will see that if we break it down correctly, it's not so bad. The diagram shows a trapezium. Here it is, which is shows the parallel sides, right? And the radius is r here. A, B, and C are on its circumference. Construct M, there's a big hint, the midpoint of CB. So if we take M and we're going to put it down here, and it's the midpoint of CB, so it's a 90-degree angle there. Hence creating the perpendicular angle, OMC, again, another hint. That tells us that these two sides are the same length. And angle OCB is theta already on the diagram. So we just had to put M on there. The area of a trapezium for OABC, we're given the result and we're asked to show it. So the area of a trapezium from the formula booklet is 1/2 A plus B times H. So we gotta just find these pieces. So A is obvious, that's R. B takes a little bit more work, we need this here. Now, we've created a right triangle. Obviously, the reason for that is we're going to need to use it. Let's call that H. We know that the radius of a circle everywhere is R. Okay? So therefore, this side here is in relation, so sine theta is H over R, which tells us that H is sine theta times R. So let's come out there and R sine theta. Do this in a bit of a different order. Now let's switch colors, make it a bit easier. Let's find this length here. So this length here is the cosine theta. So cosine theta is this length, I don't know, let's call it CM. CM over R, adjacent over hypotenuse. So B, this whole length is double that, right? This and this are the same length. So double and then multiply by R, R cos theta. So now we found each of the pieces. It's intimidating, but if you just break them down one at a time, you have 5 minutes, so you can break this apart. Now the next challenge is the algebra. You want R squared over 2 to be factored out. So let's just already move to that. Here, R over 2 times that R, and then you have sine theta. So 1/2 R times R, R squared over 2, sine theta. First part sorted. Now this R is going to multiply that R. That's going to give us our R squared. Here's our 2, so the 1/2 and the R gets factored out. And we're left with 2 cos theta sine theta. So we're nearly home free, but we got to use our double angle identity, R squared over 2 sine theta plus sine 2 theta completes the show. This is an answer given. You don't get a point for that, but you need the double angle to get there. So the formula, substituting into it, the working to show this right triangle was critical. Dropping that perpendicular, creating the right triangle, you needed the cosines and the sines in order to find the height and the length of that base there.